So this week I'm going to walk you through homework number 23. I've already set the index for the random number generator, and I've already drawn a sample of 12 cases from the first 1,000. And I've already cleared the unselected variables. So what's left to do is create a correlation matrix, which we can use to fill out this table, and then also answer some of these questions, which the answers of which are based on the output of a regression. So this week we're working with 3 variables, 1 dependent variable y, and 2 independent variables x1 and x2. And particularly we're interested in their correlation, so to get that we can say analyze, correlate, bivariate, and we're going to get the correlations between all 3 variables, so x1, x2, and also y, and we'll get Pearson correlations. So after that you can say OK, and this correlation table will pop up. The values that we're interested in are the correlations between x1 and all 3 variables, x2 and all 3 variables, and y and all 3 variables. So in this correlation table, the Pearson correlation row is what you'll be looking at. In this value here, this 1 is the correlation between x1 and itself. This negative 0.155 is the correlation between x2 and x1. And this 0.555 is the correlation between y and x1. And likewise, this negative 0.155 is the correlation between x2 and x1. This is the correlation between x2 and itself, and this is the correlation between x2 and y. And then for y, we have the correlation between y and x1, between y and x2, and between y and itself. So a few things you'll notice: the correlation between a variable and itself is always 1. That is, a variable perfectly predicts itself. And also, this matrix is symmetric, so the correlation between x2 and x1 is the same as the correlation between x1 and x2. So you can use those values to fill out this table for number 1, and then the rest of the questions can be answered using the output from a regression. So I'm going to do a multiple regression now. I'll go to Analyze, Regression, Linear. Y is the dependent variable. X1 and x2 are the independent variables. And in statistics, I'm going to grab part and partial correlations, although we might not use these yet. But I think we'll be using these next week. So that'll run. And it gives us a model summary table with R, R square, and adjusted R square. That's for the model overall. And then it gives us this coefficients table. And I'll go through and point out the relevant things in the homework now. So first question asks which variable explains the greatest proportion of variation in y. Proportion of variation is R squared, which is the Pearson's correlation coefficient squared. So when you're squaring something, it preserves the ordinal relationship between the non-squared values of that thing. So to answer that question, we can look at the zero-order correlations here between x1 and x2. I should say it preserves the ordinal relationship between the absolute values of the non-squared thing. So here, the correlation between x1 and y is 0.555. When you square it, it'll be something that'll be r squared between x1 and y. And that will be larger than this negative 0.274 squared, which would be the correlation between x2 and y. So in this case, x1 would explain a greater proportion of variation in y, and the proportion of variation that it explains would be 0.555 squared. which is the r squared for just x1. Whoa. What is the multiple linear regression model? Explain what it means and find it in the output. So in the output, you can find all the parameters in this B column. So this will be your A, 2.944 for me. This will be the coefficient on x1, and this will be the coefficient on x2. For the adjusted r squared, you can find it in the output in the model summary table. So the adjusted r squared is right here. So when you do it by hand, you can check your answer against this value. Which variable is a stronger predictor of y? Explain how you know. So the variable that's a stronger predictor of y will, I feel like this is the answer to this is the same as the answer to part 2. But yeah, the variable that's a stronger predictor of y will have the higher correlation with y, the higher zero order correlation with y, or sorry, the higher absolute value of the zero order correlation with y. So looking back here, this one's zero order correlation is 0.555, this one is 0.274. So x1 is a better predictor of y, is a stronger predictor of y. Are any variables significant? If so, which and what level? So there's a few ways to test this. One way to determine the significance of an independent variable is with t-tests on the coefficient of that independent variable. So to answer this, you can look at these significances here. And then these would be the p-values which you then compare to some alpha value. And so for me, both of these are above 0.05, which is a kind of high standard alpha. So I'd say the conclusion that you'd reach from this hypothesis test would be to reject the alternative. To fail to reject the null. And in this case, the null would be that there's no relationship between the null for this hypothesis test is that there's no relationship between x1 and y, and the null for this hypothesis test is that there's no relationship between x2 and y. So in this case, I failed to reject both of those null hypotheses, so I would say we failed to find any evidence that either of the variables were significant at a level of alpha 0.05. And I think that wraps up everything for homework number 23. So, good luck, guys.